had asked you to look at these the last time was the Charlie problem, first one on the page. And it says Charlie has an annuity that pays $3,200 at the end of every 6 months for 4 years. So I have my timeline here, 4 years, $3,200 at time 1/2 year, 1 year, 1.5 years, and so on. What is the present value 6 months before the first payment? So I'm looking for the present value right here. Assuming nominal interest rate 12% convertible monthly. So the first thing that I have done is find the monthly rate. I-12 was given, so I found I-12 over 12, which was 1% per month. And therefore, because payments are happening every 6 months, we find the 6-month rate, which turns out to be 0.0615. How many payments in 4 years? Since payments are occurring every 6 months, there are 8 payments. Therefore, 3,200 A angle 8 at the 6-month rate, I. Capital I is the 6-month rate. And you clean this up and you get 19,752.34. That's our old method. Our new method says that interest is monthly, payments are every 6 months. So I'm using the formula for payments less frequent than interest is credited. So A angle N over KI. I'm taking present value, so the numerator will be A angle 48 because there are 48 months in 4 years. And interest is credited every 6 months. And because the payments are occurring at the end of the period, I will divide by S angle K. Right? So the top is A angle N because I'm taking present value. But since the payments are at the end of the period of 6 months, it's division by S angle K. Both of them done at 1%. The denominator of each of these is I, so they will drop. The i's will drop. So I'm only dealing with 1 minus v to the n and 1 plus I to the n minus 1. And that turns out to be exactly the same answer as the method 1. Go ahead.
So I did method 2 for some reason. I used for n, I used 4, and then for k I used 1/2. And then for I used I-112. I got the same answer, but is that just coincidental?
A angle n, you used what for n?
So I did like A angle 4, I-112.
But 4 is wrong because this is the number of periods of interest in the whole time. So because it's 4 years and interest is being credited monthly, that would have to be 48.
So just coincidental.
Well, the ratio is still 8, right? That's why it worked out.
Okay.
But it's not right. Okay? The next problem, I'll post this solution so that you can stare at it more later. Joe makes contributions each year at the beginning of the year of 5,000. So my first contribution is here, times 0, 5,000. The account has a nominal interest rate 6.4% convertible quarterly. Okay, so interest, I have to find the quarterly interest, so I immediately divide by 4. So I find my quarterly rate. Find the balance in the account just before his 10th contribution. So his 10th contribution would be occurring at time t equals 9. I have 9 payments here. I'm using method 1 at first. So this would be 5,000 S double dot angle 9 because the payment is happening in the beginning. And I just clean this up at the proper rate. Just see, Joe makes contributions each year at the beginning of the year. So I have to find the annual rate, right? Quarterly rate is not good enough. So after I do I4/4, I better find the annual rate by going 1 plus I equals 1 plus quarterly rate to the 4th power. And then the annual rate is used here because payments are occurring annually. So this would be at I. And then you clean it up. So this is our old method. Nothing new, nothing changed here. Let's go here. I have a quarterly rate, but payments are occurring every 4 quarters, with the first payment occurring at the beginning. And they want the balance in the account just before his 10th contribution. So I want accumulated value. Therefore, I'm dealing with S on the top, S angle N on the top. And because payments are occurring at the beginning of the period, it's A angle K on the bottom. Right? S because I'm taking accumulated value, and A because the payment is occurring at the front end. So N is going to be 36 because I have 36 interest periods in 9 years, and payments are every 4 interest periods. So S angle 36 over A angle 4 when all is said and done, because the double dots, this S double dot angle 9 turns out to be this formula, and then I clean it up. So basically, if you can just remember that when you're taking accumulated value, the S goes on top, and because the payment is occurring at the front, the A goes on the bottom, you should be good. Right? Notice that this 36 divided by 4 will be equivalent to this 9, right? Because there are 9 payments. What is your question, Melissa?
I said, is that always?
Yeah, it'll always match up. And then lastly, a perpetuity paying $26.50 at the end of each year is to be replaced by another paying X at the beginning of every 3 years. The present value of each is $30,000. Find X. So first statement is $30,000 is the present value of this perpetuity. So A angle infinity I, which is just 1 over I. Don't rush to write this. I'm just going to post this. You just basically need to understand, right now. I'll post it tonight. So $26.50 times 1 over I. So solve for I. This will give you the annual interest rate I, because this is happening annually. And let's see, replaced by another paying X at the beginning of every 3 years. So I have to find the 3-year rate. I have the annual rate. I can find the 3-year rate, 1 plus I to the cubed minus 1. And then these payments are occurring at the beginning of every 3 years. So this will be A double dot angle infinity at the 3-year rate. Follow? So I'm using X, A double dot angle infinity, and this is the 3-year rate. So that would be X over D this time, not X over I. X over D equals 30,000, where D is just I over 1 plus I. So we put that in and we solve for X, and we get X here. And my problem is done. That was method 1, the old method. Method 2 says 30,000 equals X. I'm dealing with this. A double dot, because the payments are occurring at the front. It goes on, the payments go on forever, so I have infinity for N and every 3 years for K. So let's look here for a moment. So here you have A angle infinity, because the payments will go on forever and ever, but they are happening every 3 years, and you will use the annual rate I here. So again, I'm using payments less frequent formula. They're both A's because the top is an A because I'm taking present value, and the bottom is an A because the payments are occurring at the front. And then you clean it up. I did not need the 3-year rate here. You just need the annual rate here because interest is annual for this one. Is there any confusion at all? You're going to have to do it for yourself. It'll all make sense when someone else is doing it until you try to sit down and do it yourself, and then you will see that you will be confused as to what rate to use, what is the N, what is the K. You will have to practice that for yourself, right? So without looking at the solution, how many of you got all of these right? You were supposed to try them for today, right?
I got number 1 right, but just coincidentally.
Okay, so practice with this, and I posted the new homework. Can you see it? So 4.2 and 4.3 you should be able to do after today, okay? Let's start with payments more frequent. So I'll fill this up properly and I will post it. Let's go to, oh, what's going on with Raul? Let's do the Raul problem and then move on. Raul deposits 100 into a fund at the end of every 2 years for 20 years. Timeline. 20 years. 0. 100 into a fund every 2 years. 100 at 2, 100 at 4, ... 100 at 20. And 100 at 18. Annual effective interest rate equals I. The total amount of interest earned by the fund during the 19th and 20th years is $250. Okay, so here, 19th and 20th years is the time from 18 to 20. So here the interest is equal to $250. Find the accumulated value of Raul's account at t equals 20. Okay, so what's the easiest way to do this problem? I think the easiest way to do this problem is to find the 2-year rate, because payments are happening every 2 years. Find the accumulated value at 18 and then clean it up. So let's do accumulated value at 18. What would this be? So 100 S angle, how many payments? 9 payments. 100 S angle 9, I at the 2-year rate. So I'll go find the 2-year rate right now. How should I find the 2-year rate? You have the annual rate I? So, yeah, 1 plus I squared is the 2-year rate. Okay, so then set that equal to 250 after you multiply by I. So I, the 2-year rate, times accumulated value at 18 is equal to 250. That's what they told me. So I times 100 times S angle 9, put in the formula, 1 plus 2-year rate to the 9 minus 1 divided by I. I and I cancel. So this is equal to 250. Divide by 100, you get 2.5 equals 1 plus I to the 9 minus 1. Bring the 1 over. 3.5 equals 1 plus I to the 9. So 1 plus I equals 3.5 to the 1/9. What is that? 1.149349 is equal to 1 plus I. Therefore, I is equal to 0.149349. Find the accumulated value of Raul's account at t equals 20. How should I do? I have I now.
100 S angle 10.
Finished. 100 S angle 10 at I. So, 100 times 1.149349 to the 10 minus 1 over 0.149349. I get 2023.92. Doable. Does it work for you? I only needed to set it equal to the interest to solve for I. Once I know I, it's just S angle 10. Finished at the 2-year rate. Okay, let's move on to something new. I have to write and write and write. Let's do it. Payments more frequent. Payments are now more frequent than interest. Example, find the present value of an annuity immediate with monthly payments of 1 over 12 for 10 years at annual effective interest rate equals 0.05. So let's look at this timeline. It's happening for 10 years. Monthly payments, it doesn't say when, so you have to assume at the end of the month. So the first one is at time 1/12, you have a payment of 1/12. At time 2/12, you have a payment of 1/12, and so forth. Here's time 1, here's time 10, which is equal to 120 over 12. So the way we write the present value is the following. 1, A angle 10, 12, like this. So this is saying that 1 is the annual, total annual payment. It's the sum of these 1/12th, 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 all added together. So total annual payment is the coefficient. So that's something new. We haven't done that ever before. So you're going to add the 12 payments. That's how you get 1. And then this is saying A angle 10, because this is happening for 10 years. And this 12 is saying 12 times a year. Payments 12 times a year. So since my payments are monthly, I have a 12 sitting there. So I want to find this present value, and I'm going to take this 1/12th payment and discount it by V. V to the 1/12th, V to the 2/12ths, like that. So 1/12 parentheses, I'm going like this, guys, watch. discount, 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 and keep discounting all of them. So V to the 1/12 plus V to the 2/12 plus dot, 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 V to the 120 over 12. That's the last payment, discounted. The 1/12 has been factored out. Multiply the whole expression by V to the 1/12. So V, let's leave this present value. So I'll multiply 1 V to the 1/12 present value equals, and I want to ignore this for now. How should I do this? Let me call this S. Let me call this S for sum. I want to leave the 1/12 alone. So I won't say PV here. I will say S. 1 V to the 1/12 times S. Let's only work with this. So V to the 1/12 times S is equal to V to the 2/12 plus dot, 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 V to the 121 over 12. Subtract. So this is my S over here. S equals this mess. So when I subtract, I get S parentheses V to the 1/12 minus 1. I'm saying this expression minus the top expression equals V to the 121 over 12 minus V to the 1/12. Because the only thing that's left when I do the subtraction, everything is going to drop like this. Drop, drop, drop. The only ones left are him and him. And I'm subtracting the first one from the second. So this is what I get. So therefore S is equal to V to the 1/12. I'm factoring out a V to the 1/12 on the numerator here. V to the 120 over 12 minus 1 divided by V to the 1/12 minus 1. Divide numerator and denominator by V to the 1/12. So I get V to the 10 minus 1 divided by 1 minus V to the negative 1/12. I'm dividing everything by V to the 1/12. If I flip these around, factor out a minus 1, I would get 1 minus V to the 10 over V to the minus 1/12 minus 1. All I did was divide top and bottom by minus 1. Now this is equal to S, the sum S. But my present value is equal to 1/12 times S. So it's equal to 1/12 times 1 minus V to the 10 over, this V is 1 over 1 plus I, so this V is 1 over 1 plus I, and therefore I get 1 plus I raised to the 1/12 minus 1, like this. So this is 1 minus V to the 10 over I-12. The nominal interest rate convertible monthly. Remember the formula for I-12? I-12 over 12 is equal to 1 plus I to the 1/12 minus 1. So if I bring the 12 over, this I-12 is equal to this. And that is called, this 1/12 is now gone, so this is called 1A angle 10, 12. So notice that it looks just like A angle N, except The denominator is not I, it's I-12. Payments are happening 12 times a year for 10 years with a total annual payment of 1 because I have 12 payments of 1/12. So how much would this be? Can we clean it up? Because they gave us numbers, right? So my interest rate was 5%. So this would be 1 minus 1.05 to the minus 10 divided by some I-12, which I have to find. So I plug it in here. I-12 is equal to 12 times 1.05 to the 112 minus 1. What do you get for I-12? .04888 94. Can I call it 9? And then what do you get when you divide? I got 7.897. So my present value is 7.897. Yep. What's your question? Seems like a lot, but you're not going to do a derivation every time, right? You're just going to say, what is my total payment for the year? You have 12 payments of 1/12, so your total payment for the year is 1. How many years is this occurring? It's occurring for 10 years. So A angle 10 raised to the parentheses 12, right? That means the only difference here is that instead of going 1 minus v to the 10 over I, you're going to go 1 minus v to the 10 over I-12. Can you find I-12? Certainly. We just did it right here. That's all. Done. So this is your other option if you don't want to find the monthly rate and use the monthly rate 120 payments. Yeah.
When you're calculating the V to 10, that's with the normal I?
Everything is with the normal I. The only difference is the denominator. Yeah. So basically, A angle N 12, 1 is equal to A angle N times I over I-12. Does that make sense? Because this guy has a denominator of I, and if those I's cancel, then you will be left with the I-12 in the denominator. That's all. So you can do a regular A angle N, and then in the end, just multiply by I over I-12. Okay, so next page. What is the number of this page? I can number them later. What was the last thing I did? Was it 6? Page 5. So let's call this 5A. 5B. The given annuity with monthly payments of 1 over 12 is equivalent to an annuity with annual payments of I over I-12. I'm going to show that. I'm going to prove that to you. So at t equals 1 year, the single annual payment of I over I-12 would be as good as 12 monthly payments of 1 over 12 each. Let R be 1 over 12 times 1 plus 1 plus I to the 1/12 plus dot 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 1 plus I to the 11 over 12. I'm going to explain. Timeline. Zero, 1/12, you have a payment of 1/12. 2/12, you have a payment of 1/12. And at time 1, you have a payment of 1/12. And this accumulated value is equal to R. So I'm writing an expression for the accumulated value at time 1. That's why I can say R, the accumulated value, is equal to this 1/12. I'm bringing it here, guys. Accumulated value. So times 1 plus I to the 11 over 12 power, because this much is 11 over 12. Then I have another payment. 1/12 times 1 plus I to the 10 over 12. I'm bringing this one over. Keep going like that. This one would be 11 over 12. So this one would be raised to the 1/12th power. That is this payment right here, this term right here. And lastly, I have 1/12 times 1. You follow? I'm taking the accumulated value. My aim is to show that this R is just the accumulated value of all these payments. And it might as well just be one payment of I over I-12. That's my goal. Because if I can show that, then I have the right to do what I did on the previous page. Right? Because look what this was saying. This was saying, if you just take a payment of this once a year for n years, if you did this payment once a year for n years, it would be the same as taking a payment of 1 over 12 every month for n years. So if I could just show that the accumulated value of these guys is equal to I over I-12, I would be done. So how should we do? Again, S equals 1 plus I to the 1/12 plus dot 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 1 plus I to the 11/12. Therefore, 1/12 R is equal to 1/12 times S. So I've pulled out this 1/12. So multiply everything by 1 plus I to the 1 over 12. 1 plus I to the 1 over 12 times S thank you, equals, I'm multiplying 1 plus I 1 over 12 plus 1 plus I 2 over 12 plus dot 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 1 plus I 12 over 12, which is just 1 plus I. So S parentheses, I'm dealing with this one and this one now. So S parentheses 1 plus I to the 1 over 12 minus 1 equals, everything is going to drop here. This drops, this drops, this drops, this doesn't drop. So 1 plus I minus 1. The 1 and the minus 1 drop. And I have just I. Therefore, S is equal to I over 1 plus I to the 1/12 minus 1. But I don't want just plain old S. I want R, which is equal to 1/12 of S, which is equal to I over 12 times 1 plus I to the 1 over 12 minus 1, which is no other than I over I12. So this is the single payment. One single payment at t equals 1 is equal to 12 monthly payments of 1/12 each. Get it? So that's my justification. Keep going. Let me write on the next page. This is the justification for 1 angle 10, 12 is equal to I over I12, my one payment, A angle 10, I. Right? So I just finished showing that one payment of I over I12 is equal to the monthly payments of 1 over 12 each. So why not just take a regular annuity that pays once a year at this payment instead of taking an annuity with 120 payments paying 1/12 each at a monthly rate? So this is just I over I12 times 1 minus V to the N over I. My N is 10. 10 over I. Are you with me or no? Let's do an example. First, let me see what's on my page here. 5B, 5A, 5C. Okay, I need to do one more example before I can get here. A 10-year annuity immediate provides quarterly payments of $500 at 2% annual effective interest rate. Find the present value. Timeline. 10-year annuity. So write 10. Payments are quarterly. 1, 2, 3, 4. 500. If you're going to use the new formula and not find the quarterly rate like we would have done in Chapter 3, if you're going to use this new formula, then you have to find this total payment for 1 year. Total payment per year is equal to 2,000. That's the first thing, right? Remember, our coefficient was 1 last page. Where did that 1 come from? It came from the fact that there were 12 payments of 1/12 each. So now I have 4 payments of 500 each. So total payment 2,000, and I'm ready to go. Present value equals 2,000. A angle, how many years? 10 years. Annual rate, 2%, with a superscript here of 4, because payments are 4 times a year. That's it, finished. Clean it up. Equals 2,000 times 1 minus V to the 10 divided by I4. Not I, but I4. So I have to find I4, right? So 1 plus I4 over 4 to the 4 equals 1.02, which is 1 plus I. So 1 plus I4 over 4 is equal to 1.02 to the 1/4. And I4 is equal to 4 times 1.02 to the 1/4 minus 1. So this will go on the bottom here. So 2,000, 1 minus 1.02 to the minus 10 divided by my I4, which is 4 times 1.02 to the 1/4 minus 1. When I clean this up, I get 18,099.35.
What if accumulated value just be the same thing, just using the
Accumulated value, you can just grow it by bringing it 1 times 1 plus I to the 10th power. Right, so here I could do this, or I could have done 2,000 A angle 10.02 times I over I4. That would be the same thing. Okay, what about method 1? You remember your chapter 3 method for this? How would I do method 1? This obviously is method 2, right? What's my original method? Payments are quarterly, so find the quarterly rate. And then that would just be here, method 1. 500 A angle, how many payments if the payments are happening quarterly? 40 payments at the quarterly rate, which is 1.02 to the 1/4 minus 1. That's the rate. So 500 times A angle 40 at 0.00496293316. When you clean this up, you get the same answer, 18,099.35. It's certainly doable, right? Just a few practice problems and you should be good. Any questions? Let's see. What's my next problem? MAPI. Okay, so page 6. MAPI was offered a scholarship with level end of monthly payments for 4 years. Scholarship. Level end of monthly payments for 4 years. So 48 payments. Monthly payments. I don't know how much they are yet. Each year, the sum of the payments totaled 5,904. So can I find my monthly payment if I know the sum of them? So each payment is equal to 5,904 divided by 12, which is 492. So 492, 492, 48 such payments. Then what? Each year the sum of the payments total 5,904. He was also offered a fellowship paying 5,800 at the beginning of each year for 4 years. Okay, so I have a scholarship and I have a fellowship. $5,800 at the beginning of each year for 4 years. Timeline: 1, 5,800, 2, 5,800, 3, and 4. That's it. 5,800. Okay, what do they want to know? Compare the present value of these two offers, assuming annual effective interest rate 4%. So I annual is equal to 0.04.
For the fellowship, should it be like 0
He was also offered a fellowship paying $5,800 at the beginning of each. Yeah, of course. 0, 1, 2, 3, 4. Thank you. Zero, 1, 2, 3, 4. No 4, right? Let's see. Fellowship paying $5,800 at the beginning of each year for 4 years. This one is not there. Let's get rid of that. Okay, find the present value of each. Let's go. How about the scholarship? That's the new stuff, right? What shall I do? Talk to me. I've already divided it up into the payments, so now I know what every payment is going to be monthly. Can you use method 2? Because I already know that you know how to use method 1, right? Method 1 would be to find the monthly rate and find the present value of 48 payments. So I know that you know how to do that. Can you do it with the new way? So I have 4 years, 12 times a year. So can you please do it right now? Tell me what to do at least. Present value equals what? Oh my God. Talk to me about present value. 5,904, which is the total annual payment, right? Total annual. A angle what? A angle 4, right? Annual rate 4%, right? Payable 12 times a year, just like that. So 5,904, 1 minus v to the 4 over I-12. How much is I-12? How much is I-12? Can you help me find I-12? Let's say I'm clueless. What do I do?
12 times parentheses 1.04 to the 112 minus 1.
12 parentheses. Go again. 1.04 minus 1. And that turns out to be how much?
0.03928.
Did you multiply by 12? Okay, 0.03.
9284.
Good enough. So when you clean this up, what did you get? Okay. What about the fellowship? What's the present value here? 5,000, a double dot, angle 4 years at 4%. So this is 1 minus, is it 5,800? 5,800, yep. 1 minus v to the 4 over I, 1 plus I, times 5,800. Here I get 21,895.53. So this one was not horrible. Right? Once you find I-12, you just put it in the denominator and that's it. Okay. All right. Before you come back on Friday, can you do the Shirley problem both ways, method 1 and method 2? This one, this next problem, both methods, method 1 and method 2. Let me give you the answers. The answer here is 33255.13. I'll give you your papers back on Friday at the end of class, okay? And I'll post all the solutions. Your exam papers.
Question. So, does it matter that the two answers are kind of different?
What two answers are different? Yeah, these are two different things. One is a scholarship and one is a fellowship. And they are not meant to be equal. It's just saying find the present value of each.
Yes.
That's okay.